Welcome to EDU World Space.
So in this question, we are given the principal strains at a point on an aluminium, right? The material is aluminium, surface of a tank, right? And the principal strains are given, right? So the first strain is 630 into 10 raised to power negative 6, and the second strain is 350 into 10 raised to power negative 6, right? And if this is the case of the plane stress, we are required to determine the principal associated principal stresses, right, at the point in the same plane. And they have given us the elasticity for aluminium, that is 10 into 10 raised to power 3 ksi, and epsilon sub aluminium, that is equal to 0.33. Right now, the hint that is given to us is to see problem 10.30, right? So let's start with the solution. The solution is very simple. So um, now in problem 10.30, right, we proved the following equations, the equations that I'm about to write, right? So sigma sub x is equal to E divided by 1 negative epsilon square. Over here we have strain for the x direction plus epsilon into strain for the y direction, right? And for the y direction stress, we have E divided by 1 negative epsilon square, parenthesis, close parenthesis, right? So the strain for the y direction plus epsilon into strain for the x direction. Now, these can also be written in terms of the principal strains, right? Principal stresses, where the stress for the x direction is equal to sigma sub 1 and the stress for the y direction is equal to sigma sub 2, right? So we are going to rewrite these equations in terms of the principal stresses, right? So these equations would become principal stress E divided by 1 minus epsilon square, close parenthesis, strain, right, plus epsilon into strain, right, and the other would become E divided by 1 minus epsilon square, epsilon sub 2 plus epsilon into epsilon sub 1, right? So now what we are going to do is that we are going to use these two equations, right, to solve our question. Now, first of all, we'll use this equation. Let's say that this is equation 1, right? This is equation 2. So first of all, we'll be using equation number 1 to answer the problem, right? So we are going to use that, right? And we have all the variables, right? The values for all the variables. So I'm just going to plug them in over here. So sigma sub 1 is equal to 10 into 10 raised to power 3 1 minus 0.33 square, parenthesis, 630 into 10 raised to power negative 6 plus 0.33 into 350, 350, right? There is no point over here. So 350 into 10 raised to power negative 6, right? So this is equal to 8.3661 KSI, that is approximately equal to 8.37 KSI, right? This is solution for part um, 1, right? And next we're going to use equation number 2, right? Again, we have all the values for all of these variables, so I'm just going to plug them in over here, right? So the other principal stress is equal to 10 into 10 raised to power 3, 1 negative 0.33 square parenthesis 350 into 10 raised to power negative 6 plus 0.33 into 630 into 10 raised to power negative 6, right? So just calculate it and we'll get that the other principal stress is equal to 6.2608 KSI. That is approximately equal to 6.26 KSI, right? So this is your solution.